Now we are going to discuss about synthetic unit hydrograph. So here, before discussing about synthetic unit hydrograph, what is the purpose of synthetic unit hydrograph? Right? We want to determine the discharge of a particular river, but there is no gauge readings. So once we have the gauge readings, that means discharge ordinates as well as time. By using that, we are going to construct the unit hydrograph and also determine the storm hydrograph desired or required duration or the different intensity of rainfalls. But here there is no gauge readings, but we have only storm, that means rainfall depth, and also have characteristics of that particular catchment. We want to construct the discharge of a particular river, but this is possible in accessible points. For example, if the one river is flow in a hilly areas, there is no possibility to provide a gauge to take the ordinates, that is the discharge ordinates. And in these situations, we are going to use this synthetic unit hydrograph. Synthetic unit hydrograph gives the discharge or gives the hydrograph by using the storm and basin characteristics. Scientists have developed this technique. They have conducted 25 to 25 square kilometer catchment area. Different experiments have conducted on this much of area, and finally they have given some formulas. Right here they have given some definitions of different heads. Here basin lag. Right, before going to discuss about basin lag, what are the items required for the construction of hydrograph or for the construction of unit hydrograph? For the construction of hydrograph, we should require, that is the horizontal axis, that are the base period. One is the base period, another one is the discharge ordinates, and also peak. What is the peak discharge of the particular rain or particular storm? What is the width of that hydrograph? All these heads are necessary for the construction of unit hydrograph. In view of that points, they have given some formulas here. Basin lag. So already I told you what is the definition of basin lag. Basin lag is the duration. It represents is the duration between the centroid of the drainage basin to the peak discharge. Here scientists have given one formula for the calculation of basin lag, that is denoted by Tp. Tp equal to Ct into L into Lc power 0.3. Here Ct is depends upon the basin characteristics, and L is the total length of the basin. This is the, for example, this is the drainage basin of one particular river or one particular stream. This is the entire drainage basin. From this point to this point, this is the gauge point, this is the furthest point, this is the L. L is nothing but total length of the drainage basin. Lc is the distance between the outlet and the centroid of the basin. This is the Lc. Right? This is the formula for the determination of basin lag. And then once we know the basin lag, by using that value, we are going to determine the peak discharge. That is also one of the parameters for the construction of hydrograph or unit hydrograph. Right here, peak discharge QP, this is denoted by QP. Peak discharge equal to 2.78 Cp A divided by Tp. This is the formula. Here Tp is the basin lag, A is the catchment area, that is in square kilometers, and Cp is the parameter that is also depends upon the characteristics of the drainage basin, that is varies from place to place. Vamsdara river having different Cp value, Nagavali river having different Cp value, and also in case of Krishna river also having a different Cp value. Right, this is the formula. And also this is the total discharge per unit area. Discharge per unit area is equal to total discharge divided by A. This is 2.78 Cp divided by Tp. So here we have learn about two parameters. One is basin lag, we have one formula, another one is the peak discharge. These two parameters are required for the construction of unit hydrograph. Next one, base period. This is the important parameter for the construction of hydrograph or unit hydrograph. Base period is estimated by using this formula, T equal to 3 plus 3 into Tp by 24. Tp is the basin lag. Already we calculated. This is the base period. Here, by using this formula, we know the base period and we know the peak discharge, and also calculated the basin lag for the location of peak discharge. And also one more formula, that is unit duration. Unit duration equal to Tp divided by 5.5. Here Tp is the basin lag, that is also determined earlier. These are the formulas, these are the values used for the construction of hydrograph. Here, this is the TR is the unit duration, Tp by 5.5. Yes. Okay. Here another one. This is the correction for actual duration of the storm. For example, they want to construct the unit hydrograph of 3 hours unit duration. They have given some values. This is the catchment length. This is the center to outlet length. These are the characteristics of the soil. Cp is equal to some value, Ct is equal to some value. So based on that, we are going to construct the 3 hours unit hydrograph. So before going to that 3 hours unit hydrograph, you determine the value of Tr here. Tp is calculated by using given values, that is the length of the drainage basin, Cg to outlet of the drainage basin, and Cp value of the drainage basin. Then divided by this value, you have some value. This value is suppose 1.5. Unit hydrograph, that is the unit duration determined or calculated unit duration equal to 1.5. But our desired, required unit duration is equal to 3 hours. So here both are not equal. If the calculated unit duration is equal to 3 hours, desired unit duration is also 3 hours, then go to apply these formulas directly. Now we are going to apply correction because both are not equal. Calculated unit duration is 1.5, required unit duration is equal to 3 hours. So then we are going to apply correction. Right here, how do you can apply correction? You know the formula for the determination of basin lag. This is the standard formula already I have given. So this can be modified by like this. Here Tp dash, the modified basin lag, equal to Tp dash is equal to Tp, that is the basin lag already we calculated by given data, and Tr dash is the desired unit hydrograph. For example, 3 hours desired unit hydrograph duration. Here Tr is the calculated unit duration. Already I told you 1 point. This is example values. Desired unit duration is equal to 1.5 hours. 3 minus 1.5, this value already calculated, divided by 4, we have Tp dash. This is the modified basin lag value. This modified basin lag value is used in further. Further means we are going to estimate the peak discharge. We have one formula. In place of peak discharge, this is the peak discharge formula. Here instead of Tp, that is the earlier basin lag, now you are going to use Tp dash, modified basin lag. Like that you are also used for the determination of base period. Okay, these are the modified values. So this is one problem here. How to construct the unit hydrograph by giving the characteristics of the basin and area of the basin. Here derive a 3 hours unit hydrograph. 3 hours unit hydrograph for an ungauged basin, because there is no, not possible, there is no any gauge readings for a following data. Length of the drainage basin equal to 32 kilometers, length CG equal to 25 kilometers, area of the catchment equal to 325 square kilometers. CT value given, this is useful for the construction of basin lag, and CP value also given, this is also useful for the construction of peak discharge. So first of all, we are going to determine the TP. Once we know the TP, then only estimate the unit duration. Based on the unit duration, we are going to apply or not apply the correction. That will decide it. First of all, what is the TP equal to CTL into LC power 0.3. All values substituted here given was, then we are having 6.7 hours. This is the basin lag. As per values, the basin lag is equal to this one. Now immediately we are going to construct the unit duration. Unit duration equal to, this is the unit TP divided by 5.5, that is equal to 1.2 hours here. The calculated unit duration is equal to 1.2 hours, but required desired unit duration is equal to 3 hours. These are not equal. Now we are going to apply the correction here. Then again we are going to construct the basin lag by using the correction. TP dash is equal to TP. This is the value of TP. Already we calculated here. Then TR dash minus TR divided by 4. TR dash is the required duration, that is equal to 3 hours. TR is the calculated unit duration, that is 1.2 divided by 4. Here we have 7.2 hours. Basin lag equal to 7.2 hours. This indicates that is the duration between the center of the drainage basin to the peak discharge. This is equal to formula. Finally, you have peak discharge is equal to 225.9 cumex, and discharge per unit area is equal to 0.695 cumex. Then base period. You know the basin lag and you know the peak discharge. These two values are required for the construction of the graph. Apart from that, we should know the base period. Base period is equal to, here also you have to use corrected value, that is equal to 3 plus 3 TP dash divided by 24. TP dash value we know. Finally 3.9 days. That discharge flowing on a particular river is for that rainfall is 3.9 days. That should be converted into hours because we all are put it in hours. So 3.9 days equal to 93.6 hours. This is the base. We know the base, we know the peak discharge, and we know the basin lag. Then we are going to construct the hydrograph, unit hydrograph, right? We know the peak discharge and know the horizontal axis base period, and we know the basin lag, and what is the width of the hydrograph width. So that values also required. For example, this is one location, this is another location, this is the hydrograph. This hydrograph can be constructed like this, or like this, or like this. So we should have some width in between. For example, this is the basin lag. This is the base of that hydrograph. From base of the hydrograph to 50% of height, what is the width of the hydrograph. Then 75% from the bottom, from the base, what is the width of the hydrograph. We need that two values, then only we are going to construct the structured hydrograph. Right here, for that purpose, we calculated here W50 means that is the width of the hydrograph at 50% height from the basin equal to 5.9 divided by, this is the discharge per unit area power 1.08. This is having 8.7 hours. 50% width, 8.7 hours, so 75% width, that should be less than. This is the graph gradually decreases at 75% height from the base, the width should be less as compared with the 50% depth. So here the formula is Sanders given this formula 3.4 divided by discharge per unit area power 1.08, that is equal to 5 hours. This is 7.8 hours width at 50% height. At 75% height, the width of the hydrograph is equal to 5 hours. We have this base period, peak discharge, and also basin lag. Now we are going to construct the hydrograph here. Right? Here, these are the base period. Base period is equal to 92 hours. 0, 10, 20, 30, 40, 50 like that up to 90 and 100. This represents base period. And also we have peak discharge, where we are going to locate this peak discharge. So peak discharge from basin to here is 22 point something. Okay, this is okay. We are going to construct this horizontal line that should be here or here or here, where the peak discharge located. For that we calculated basin lag. Basin lag means that is the centroid of the drainage basin to the peak discharge duration. Here the duration is equal to 7.2 hours. This is the 3 hours unit hydrograph. We are constructed here 3 hours unit hydrograph. That means 3 hours means center of the 3 hours. Then we are going to draw the one distance, that 7.2 hours here, then draw one horizontal line. So this is the horizontal, this is the one vertical line like this. This is the peak discharge 42 point something, and this is the location of distance from the vertical axis, that is the y axis. Then this is the peak discharge. Once we know the located here peak discharge, this is the starting base period 0 and ending base period 92 hours. Then how this graph will be constructed? So if there is no these two widths, 50% width and 75% widths are not available, this graph can be constructed like this, or this graph can be constructed like this. So here this width is, for that we have determined the width of the hydrograph at 50% depth from the basin is 8.7 hours. That means from the center point, this side half, this side half. Then here also from this side I have 2.5, this side 2.5. Then this is 1 point located here, 1 point located here, 1 point located here, and here also 1 point located based on the 75% drop, 75% width of the basin. Width of the hydrograph, and 50% depth width of the basin. Here we are also going to locate 1 point here and here 1 point. So then we are going to draw the hydrograph with a smooth curve, starting here, touch this point and touch this point and peak discharge, and again touch this point, and like this. This is the unit hydrograph of the required 3 hours unit hydrograph.